Okay. Huh. I want to see something real quick. Yeah, you barely see that. Okay. So, alright. So, geometry is gonna be a pain in the ass to actually do. So why don't we do some of that? Fixing. No, we'll do that later. It's still a pain in the ass for me to do. Oh, this is actually a cool thing. I like this thing. So we're doing this instead because it's very cool. And it's part of algebra 2 if I remember correctly. Um we can do it here, I guess. So what this question is an electricity question that if you're ECE, you actually do this. Um, this circuit is actually a circuit, I think, like, I don't remember, it was something like this, if I remember correctly. Something like that. I don't remember correctly, but it's a circuit and there's a thing you can do with it. But what we need to get idea is what possibly could be that. So what possibly could be R1. Now, I like to do this when we claim theta here, omega here, and then we do V0 equal 1 half Vi plus 1 half, and then we do V0 1 plus omega equal omega plus Vi. Okay, we got somewhere, right? Now, with that said, what can we solve with this? So what I would do here, omega plus Vi, and then we'll say VO minus 1 omega equal Vi minus VO. Now we have VO over here, so what we're really saying is Vi minus VO divided by VO minus 1. Excuse the V, the my writing's a little off. Okay, so omega, if you plug this in now, equals Vi minus 1 half of Vi plus a half divided by 1 half of Vi plus 1 half minus 1. What does that equal in the end? So omega equal, if you look at this, that is 1 half Vi plus 1 half divided by 1 half. Wait, something's wrong. What did I do wrong? What did I do wrong? There's something wrong with this. Let's go over here. It's minus, and that goes over here. That's minus. VO. This is negative because we cross through that. So this is negative. And then this is Vi minus 1 half. That equals 1. So that tells us R1 equal R is one possible solution. Is it the only one possible? No. I'm sure there's more than that, but this is a logical conclusion we can make that in the real world would have actual applications in the EC department, unlike other valuable values you can put in here. I'm pretty sure that if you could consider 0 as 1 if you wanted to, which if I remember correctly does not do it and does not help you in any way, equal Vi, and then you just plug this in here, and that would equal plus 1 half equal Vi, and then as you can see, you can say that minus 1/2 minus 1 vi equal negative a half, and then vi equal negative a half, I think. So that's 1, right? And then that 1 equals that, so vo equal vi, so that equals 1. That is one possible, and then that should, let me see, let me make sure that's correct. Yeah, that's one thing you can get here, but that doesn't have any real value. It's just saying nothing. Um, so, but yes, so another solution could be that r can possibly equal 0. Can the bottom reciprocal be 0? Not mathematically, that would be not a sound equation, because that would be a number divided by 0, which is infinity, which is impossible. Infinity is a constant in calculus, and is, you know what? Sure, actually, it is a constant in calculus, so we actually need to look for it. So then we have VO 1 plus infinity equal infinity plus VI. Actually, this is a possible solution. So infinity equal infinity, which means the voltage is infinity, or the voltage is, yeah, it has to be infinity. So um, somehow R1 equals 0 in this thing is possible, but it kind of tells you that you need infinite voltage, which basically says this is stupid. Uh, right? Right? Yeah. This also is dumb, right? Right? Because why would you want a no change difference between these two when you have two systems of equations? You want something done. Now that's 3 solutions. There needs to be 4 of them. So what's the last possible one? That is completely useless, but I do not know. Huh. It's a good question, actually. How about if v1 vi equal 1? Oh no. That has to be v equals 0, and then vo equal half. That could be possible. Now that equals a half. 1/2 1 plus omega equal omega. So that's also possible. So then this is a possible solution, right? Omega minus 2 equal 1/2. Well, that's omega equal negative 1. So that probably is another solution, negative 1. Which would make this 0, which will make this into V2, and then Vi equals 0. So that makes no sense. So yes, it could be 2, or can be negative r. I think that's the 4th solution, but that makes no sense. Absolutely no sense. Am I correct about that? Who knows? We'll see about that. I don't know. They would have to double check that, actually. Oh well, we'll see how that turns out. And actually, yeah, if I never put something in the corner. No, I don't think I have that problem. So we're gonna have to do a new Jamboard now. So why not make a new Jamboard already? Great. Now, what else do I want to put in here? Oh yeah, this is actually wrong. Um, because this is actually like something like this, I believe. Something like that is actually the right answer. I'll fix this later. That's not hard to fix. These graphs, these are overhaul. Honestly. Oh yeah, this was fun to do. This was torture. Oh fuck, I remember that. Even though it's important. Hmm. Vector rules, yeah, that's important, but that's not. Why don't we do something from here? Calculus. Huh. Oh, we did. I did do this. This is the most basic thing I told you about. Everyone gets to do it. I did not realize that this was basically the Pythagorean theorem when I was first taught that. That was later on. Um, hmm. Yeah, I should write this as the operator. It really is just an operator. Never really thought of it that way, did you? Hmm. Oh, this was a fun one. Not really, that was torture. Um, yeah, why not do this question? Oh, I did it already. There's two different ways to solve this. Most textbook just shows one way. I like to show both ways. Um, yeah, I hate doing it the one way. It's just painful and asshole-ish. Oh, I remember this one. That's a dumb question if you ask me now, but back then I thought it was a smart question. Um, yeah, the integral of cosine. Okay, that's a bad pen. Cosine dx is equal to this equals to 1. So that's the integral of dx, which equals x plus c. If you were doing an integral of sine dx, that's a very small digit. So what would happen is, if you look at that, it's like a very infinitesimal small, goes to 0. But and this is just basically going to 0. So this would be integral of dx. So this is equal to x plus c. There's other weird operators where you do AT, and this A is a matrix like this with eigenvalues that we learned. This is actually equal to theta, the operator, which is equal to the inverse is minus A, -1. These are actually equal to each other in equivalent, if I remember correctly. And then this A is a matrix that goes like down, theta, 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 and you can get eigenvalues here, which means that this is Beagle stable because eigen, you can say that, which means that if you have a determinant of this equals 0, you're good. Uh, if you're doing a control system problem, which is a different equation, you're good.